Hey, Connie, I'm so excited to have you on the podcast. How are you doing?
I'm pretty good. How about you?
I'm fantastic. I'm so excited to jump into this conversation. We've not really talked about clean tech or anything so far in the podcast adventures. So I want to jump right in with you. What makes your batteries so special? And I want you to explain it to us like we're 5-year-olds and compare it to traditional batteries.
Okay. Well, obviously, we're just the gayest battery in the world, which by itself should make it the most awesome battery in the world, obviously, right? In terms of what makes it quite different, I should probably preface this just a tiny bit because the media tends to make it a little bit confusing. But there's two parts to battery manufacturing. There's the cell manufacturing, which is effectively like making a small little container of gasoline. I actually, if you're watching, have one in my hand. Um, and it's much more the chemistry, the mixing of slurries and stuff like that. The second part is making or manufacturing the battery packs, which is kind of like the engine that makes it work. And that's the part that we do. So we effectively make almost a battery computer, if you will. So we manufacture PCB boards and what it does, and all the wiring and harnessing and things that go with it. But ultimately, what we're doing is we're making the energy in that cell accessible. By itself, it's not super usable. When we talk about lithium batteries, we're usually talking about many, many, many cells combined into packs, and then many, many, many packs combined into really big systems. So what we do is we really have two kind of key components to our technology that's quite unique. The first has to do with how we address them. So if you thought about your laptop, when you connect to a network, no matter where it is, your laptop is able to say, hey, this is Kalen's laptop. This is where I am today. And it gives it an address to be able to send messages back and forth. Uh, well, batteries don't have the ability to do that themselves. There's very little memory to work with in there. So they have what's called a dip switch. And it's a little binary switch, like little on off switches that somebody goes and sets a code so that you can say this is battery pack one, this is battery pack two, etc. When, with a big array, say something like a grid array, that could be 100,000 packs, and you've got somebody manually going and setting this, and that somebody is probably an engineer or an electronic technologist or an electrician. So they're not cheap in terms of labor costs, and it makes the process of deploying batteries and renewable systems quite expensive, and it makes it hard for systems to go out to temporary and remote work. So, like construction camps or communities in the northern parts of Canada, etc. So what we did, the first part of our technology is we actually got rid of the dip switch so that batteries could be intelligent. And when we said we have that 100,000 packs in an array, when we turn them on, every battery will number itself. Someone will identify itself as leader and everybody else is a follower. Now, in other batteries, what happens should there be an interruption to a pack? It's kind of like cheap Christmas lights. If one pack goes down, they all go down. So in our case, that doesn't happen. What happens is, say, one cell in a pack is starting to overheat. Maybe it's a malfunction cell. There was a problem in production. That battery pack will isolate itself from the array, and everybody else will reassign itself as leader or follower as necessary. And it does it effectively instantaneously. So before information can go back to the controller that would control the whole system. So effectively, you could put together packs anywhere, anytime, without a technologist and create a microgrid, which is something that you couldn't do with any other type of technology. So it gets rid of a lot of that cost that's upfront from all of that work, and it makes it a lot more accessible. Does that part make sense?
Yes. So when you were talking about all of this, I was thinking in my kind of little person brain of like how I understand batteries. And I used to be a flight attendant in my old previous life, and battery
Okay.
fires were one of our number one things that we had to be conscious and aware of how to deal with them and that if it happened on board. And they always talked about like the lithium like knock-on effect or the run-on effect. If one was to explode or light on fire, it knocks on to the other ones and how to stop that run-on effect and all that. And so I'm thinking in my head, I'm like, on a larger scale, that is like eliminating that knock-on effect. Is that what you were kind of talking about, how it isolates and stops.
Partly. Yeah. So
Okay.
what you're talking about is called thermal runaway.
Yeah.
And different chemistries actually have different thermal properties or likelihood of thermal runaway. So the media always talks about lithium ion as though it's one type of battery. It's actually a group of chemistries. So it could be nickel, magnesium, cobalt, lithium iron phosphate, solid state lithium, lithium zinc, lithium air, on and on and on. So it's actually a lot of different chemistries, and each of them have different properties. So, like nickel, magnesium, cobalt, for example, is much uh, more likely to catch on fire and to have that fire propagate than something like lithium iron phosphate. But nickel, magnesium, cobalt happens to be much more energy dense, which means you can pack more energy into a small container, which makes it good for things like electric vehicles. Whereas lithium iron phosphate, a little less energy dense and more frequently used like things that are stationary. So that's a little chemistry lesson for you. But yeah, you're on kind of the right idea. And part of what, and kind of going on a little bit of a tangent here, but part of what the packs do, one of their primary responsibility is protections. So most battery packs have one or two levels of protections. We actually have three. I'm not sure if there's any other packs that have three. There might be. Not positive, but effectively what we do is we watch for things that might cause the battery to overheat, for example. So if you try to discharge it too fast, it might shut it down. If you try to charge it too fast, it might shut down. If there's a fire in the area and things are just getting too hot, like so not the batteries are on fire, but say it's near something that's overheated, or just in general, the ambient temperature gets too hot, it can shut down. So there's a lot of different things that could cause a battery to be in an unsafe operating temperature or range, in which case the protections are meant to shut it down. And it might shut down one pack or it could shut down the whole array, depending on what the problem is. So it's interesting on the, you mentioned airplanes, because one of the things that's a real frustrating thing in this space is that IATA, so the group that controls regulations for batteries on planes, what they look for is how much energy is coming on board and not certifications. So if you take on a small battery pack, it might not have any certifications or any protections, but it's small, so it's allowed on the plane. It's actually kind of scary. um, but you could have a larger battery that, say, exceeds the 100 watt hours, but has all of the certifications. That actually, in my opinion, is a much more safe item to allow on a plane. But it's a tricky thing. There's a lot of misinformation out there in general, and I think sometimes people are making decisions and rules that are maybe not always best informed or might be on outdated information. So it's interesting. I actually think the bigger, more important thing that for IATA and planes to be looking at is not how big or how much energy are you bringing on, but how safe is that energy, right? So
Yeah.
that's the protections and stuff like that. I totally digress there, so
That's
I'm
okay.
gonna
We'll bring it back. We'll bring it back. So we're talking
sure.
about you, your company, your batteries, your large scale batteries. We're not talking you go into the store and buy a battery. We're talking like large scale industrial type batteries specifically here with you today, correct?
Yeah, it's yes and no, actually. So I'm going to step back for one second because you asked about what makes our batteries so cool. So I told you the first part, which is that auto addressing and self-identification part. The second part is actually on security. So right now, like I mentioned, we have PCB boards that kind of work like computers. Battery packs don't actually have any security for the most part. In fact, almost none. There's a couple of packs out there that have some really rudimentary type stuff, but otherwise there's nothing. Well, that becomes an issue when you start looking at where things are going. So I actually was on a podcast for NASA at the beginning of June, which yeah, totally cool.
Yeah.
Who gets to have a conversation with NASA's lead futurist? I was like, it's pretty well. But one of the things we were talking about is that we're moving into a space where we're starting to see energy ransoms. So if you want, say, Amazon to cut you a check, take down their power. Watch how fast they cut that check. So batteries happen to be a very vulnerable part of the energy systems because right now there's very little to no security. What is available is third party kind of surface fixes, if you will. So instead, what we did is we took um, our technology and made it very, very secure. And we did that by we put 256-bit encryption on each pack, which is double what your computer typically has, which is 128. So we took 256, but then we tied it to that leader follower stuff I was talking about. So if you tried to hack our system, and you were able to hack the 256-bit encryption on one pack, it would simply isolate that battery pack from the array and nominate a new leader and followers. So the only way you could actually take down our system would be to simultaneously hack all 100,000 packs, which even with quantum computing, we don't have the processing power to do it. So while nothing can truly be said to be unhackable, there's no known technology we have today that could beat this system. And the bigger the array, the safer it is. So that's pretty unique stuff to us. I don't believe there's another system out there that I've seen that's even close.
I'm just nerding out because you're just so cool. I just, like we're just getting into this conversation. I'm like, this is like the cool. I love when somebody's so passionate about what they're talking about, and you clearly are so passionate and you know all of your stuff. So I'm just like, I'm tickled pink right now. Um, I want to say your tagline on your website is ethical energy is achievable. How are your batteries actually helping to achieve that statement?
Yeah, you know what? And again, this is one of those things where the media can unintentionally, I think, be a bit misleading about what some of the issues are in batteries. So one, we hear, if you haven't heard, you hear a lot about cobalt and child labor, for example. Well, you know how I mentioned that lithium ion is actually a group of different chemistries. Well, nickel, magnesium, cobalt uses cobalt, obviously. Uh, the other types of chemistries like lithium iron phosphate, which we predominantly use, don't have that. So we specifically choose a chemistry or any of our chemistries that we use. We choose ones which do not have that ethical issue. There's other parts to it in terms of when you actually manufacture a battery pack, if you could think about like a lithium iron phosphate cell typically looks like a D Duracell cell. It's a little bit bigger, but pretty similar to that. So when you put them together in a battery pack, they're typically spot welded into series and parallel as you need. Now, here's the challenge. If you have one cell fail, which let's face it, manufacturing processes have some level of failures, right? So if you get to the end of the production line and you go to test and one cell has failed, all of the cells in that pack go to waste. So a typical pack would probably have 272 cells. So one cell fails, 272 go in the garbage. That's industry standard. It's a huge loss. So even though it's slightly more expensive and a little bit more time consuming, we actually don't spot weld. We use a nut bolt combination so that should one cell fail, we replace one cell. So those are kind of the things that we do. Like we look at our supply chain. Where are we getting it from? Like where are we getting our components from? What is their practices in terms of ethical treatment of people, ethical treatment of the environment, etc. So there's a number of things, but those are a couple examples.
Okay, so there's not only is there efficiency, but there is conscious awareness of where you're sourcing products and materials from, what other suppliers you're going through, which is really important. And I think that a lot of today's entrepreneurs and today's future big conglomerate companies are very aware of that and understand that that is the only way we're going to get to sustainability in the future because, younger generations are the ones who are still going to be around to have to deal with it. So we're really
Absolutely.
baking these things into our companies. So that makes me really happy to hear and to know that you are taking that on. And I'm just, efficiency is one of my favorite words. It's how I love to run my life. It's how I love to do business. And when you can make something efficient, even if it does cost a little bit more, it saves you so much more in the long run of things. So
Yeah,
that
and honestly, it's not even that much more. I couldn't give you an exact number, but we're not talking like the battery is 15% more expensive to build. It's maybe a couple percent if I had to guess. I don't know other people's numbers well enough, their internal numbers, but I'm going to say it's not huge.
Yeah.
So it's something to me that it's almost inexcusable to not find better alternatives. One of the other things that we did that was uh, kind of forward looking in this space in terms of trying to limit our footprint is our very first R&D project we did with the Canadian Department of Defense. We wanted to create a system that was very forward looking. And we said, okay, well, here's a group that's going to use batteries of every size, and they're constantly needing more batteries. As one battery runs out, something else might be brought on. Now, if you have most systems and you're, say, using lithium iron phosphate, and solid state lithium has just become really commercially viable, and you want to switch to solid state lithium, well, you would pretty much have to replace all of your existing equipment, even if some of that might only be a few months old and well, but lots and lots of life still left. So what we did is we actually, one of the projects we did is we made the system so that you could stack the batteries without cables, and we made them really small actually. So you were saying about size. We made these like the size of a power bank, that a slightly largish power bank, but that an individual soldier could carry in the field. And what we did is we made them in 3 different chemistries. And then when you're out in the field, you could stack them together and they would create one microarray, regardless of the chemistry. So effectively, what we did with the electronics is we were able to say, okay, you're going to watch for different voltages and you're going to adjust the system based on those different voltages. So this way, if they decided to move to solid state lithium, instead of replacing all of their existing equipment, they just start adding new. And for a lot of groups, whether it's the military or somebody else, that's a really big difference in terms of your environmental footprint and your cost. I actually, I kind of had this thing I call a philosophy I call planned advancement, and the opposite. It's meant to be the opposite of planned obsolescence, right? So we look at the design process and say, how can we look at this design in terms of what it's going to mean tomorrow as people go to replace, as pieces of technology advance, and then trying to design such that we minimize the number of costs or changes that a user would have to incur.
Yeah, so it's efficiencies across the board. It's not just one little specific thing. It's
No.
multiple different layers of where you're looking at where can we be sustainable, where can we be more efficient for everything and everyone across the board. I want to know, diving deeper into the sustainability, what specific things have you mandated just in your company or organization to continue on making sure that these batteries are more sustainable into the future?
Well, I'd like to say we have everything down in policies, but we're not that good. Being a smaller company that's still growing, a lot of that's still happening. But what we do is we review it all the time. So we're constantly, as a team, whether it's at our safety meetings or our team meetings, we're looking at what is the processes that we're using, who are the vendors we're using, et cetera. So it's baked into how we operate in general. And everybody is encouraged to look for those opportunities to do better. So whether that's you don't have to be in the department, if you know what I mean. So you don't have to be a technologist to say to the technologist, hey, have we considered X? Would that make this more environmentally friendly? Would it make it operate better? So we really try and foster I guess, a climate internally, or a
Open communication,
yeah, open communication
no
and a sense of,
silos,
yeah, and an openness to innovation. I always have this saying, like, no great invention was ever made on the first try. It always takes many, so you can't be afraid to fail, and it's okay. So we try and make sure that people feel comfortable sharing ideas, knowing that there's not going to be a cost to that in terms of how they're treated in the company. They're not going to be looked down on. They don't have to worry that they get it right. Somebody might say, "Oh, you know what? We considered that, and here's why we can't use it," and that's okay.
right?
And
Because then
sometimes
you
we get really
learn.
big wins. Exactly. Exactly.
Yeah, it's the failing forward, and everything is a learning experience. And if you approach it, there's this really great book by, oh, what's her name? It's now that I'm like a pressure that on to like remember. But
Naturally.
she talks about the type of mindsets that we grow up with. Mindset by Carol Dweck. Whew, there we go. And she talks about how we grow up as children and what we're taught, and we're taught for the outcome. We're not taught for the journey. We're taught for the A. We're taught for the win. We're not taught for, wow, it must have taken so much energy for you to learn how to get that A. It must have taken you so much training to earn getting that win. And we need to praise the journey, not the outcome. And when you have an open mindset and a learning growth mindset, that's what you're doing. You're praising those things. And it sounds like in your company, you're praising the journey, not necessarily the outcome that is coming from it. Wins are great, but getting there is so much more important, and the journey that you're actually taking.
Absolutely. Couldn't agree more.
Yeah.
I'll have to read that book because I
Yeah.
haven't actually.
Oh, it's a phenomenal book. I love that book. So you're based in Alberta. Uh, it's actually been having kind of, some experiencing some, news lately, and maybe been calling it a energy crisis of sorts. Can you explain what the problem is and how Alberta might be able to overcome this in the future, and how maybe your company might be able to be a part of that solution?
Yeah, it's a jumble. It swings back and forth a lot, I find, in terms of support or lack of support. Um, and I find the biggest difference is between rural and urban. So the majority of Albertans live in either Edmonton or Calgary, obviously the two biggest cities. And within those cities, you'll find that generally speaking, support for sustainability, renewables, et cetera, is very high. In the more rural areas, less so. I mean, quite plainly. And so the political environment tends to swing based on where their party support is. So right now, the current party, the UPC, definitely has a lot more. I saw that face. I'm going to keep mine in check.
I'm just gonna
Uh,
sip my tea.
mhm. Yep, we're same page. So right now, the current premiers, a lot of the support comes from more of the rural parts of the province. And so there's definitely a push to look at alternatives that are not renewables, which to me is a bit of a step backwards. But we've also seen in recent months a bit of a shift in that. So for a while there, it was really they didn't want to hear anything about renewables or batteries, etc. I heard a statement just maybe a little over a month ago by one of the provincial ministers who was talking about the need for batteries and how much they want to support that. So I think it does vary. I think it jumps around a lot, but the bigger driver by far is business. And business is very, very interested in renewables. The cost savings, the environmental impact is well established. And people want to be able to take advantage of that. So whether the government wants to get behind it or not, there's a lot of folks out there who simply want to look for a better solution. And one of the things a lot of people don't actually recognize is they think that batteries are not don't have a positive cost or environmental impact unless they're paired with solar or wind. But it's actually not true. Actually, I'm going to use Ontario example here because the numbers are a bit fresher in my mind right now. But there's a couple of different things that play in. So first off, when you look at the cost, if you're a residential user of electricity in Ontario, you pay different rates at different times of day. So I think the newer numbers are about 2.5 cents for electricity overnight, but then about 23 cents at dinner time, right? So you pay different amounts. And it has to do with managing the load that has to go over the electrical grid. And they want to incentivize people to not use electricity all at the same time, right? So one of the things you can do with batteries, for example, is you buy the electricity overnight, store it in the battery, and then come dinner time, you use it from the battery. That by itself actually drops bills often 30+%. So that's a pretty big, significant difference. And of course, it also gives you a backup. The environmental piece to it actually has to do with what's called average versus peak emissions. So at times when the electrical load is lower, when we're using less electricity as a group, the grid operators are better able to use renewables. So they can say, okay, let's pull up as much wind as we can, as much solar, et cetera. And they're going to try and draw from those. But when things get really busy, when the load is at its highest, is when they have to turn on what's called peaker plants. And peaker plants are typically, this is globally speaking, they're going to be coal and natural gas is often what comes online. So they're much dirtier producers of electricity, if you will. So the amount of emissions that's produced for the electricity you use at dinner time has more emissions than that which you used overnight. So, and the difference is somewhere in the range of about 39 grams of carbon dioxide equivalents when it's overnight per kilowatt hour. And then at dinner time, you're looking at about 420. So it's a huge, huge jump. So sometimes smart application of batteries can have a really, really big financial and environmental impact, even before you add solar. So solar often actually pays itself off slower. So, we have systems where, the batteries will pay themselves off in, say, 2 years, and it takes 9 to 10 for the solar to pay itself off. So that's usually quite a surprise to a lot of people because we're used to, like, even 10 years ago, the cost of batteries made it far less economical. But now, with the shift in costs, um, more batteries on the market with better technology, lower costs of production, it's started to change. So within Alberta, to get back to your original question, um, I mean, I really think that cost savings and the environmental impact is what drives the purchase, and the government policy less impactful than you might think.
Okay, interesting. I want to do a pullback and
Okay.
do more of a grand scale of like what are some of the issues affecting the power ecosystem in the world
Mm,
and going into the future. So
sure.
if you can speak a little bit about that, about like where this is being positioned currently in the world's ecosystem and how it can move into the future to be more of a successful renewable energy source or a successful, more eco-friendly source.
Sure. I mean, there's a number of things there. I mean, personally, the whole reason I ended up starting the company, starting Grengine, was because I wanted to take on the problem of energy poverty, global energy poverty. It's honestly, there's three numbers that I think every person should know, and very few do. The first is that there's still about 1 billion people who have zero access to electricity. So that's energy tier zero. That's what, 1 in 7 people. It's not small. It's about 2.6 billion ish that don't have enough energy to cook in any way other than to burn something. And a lot of times that might be even burning garbage. So environmental impact is huge and the health impact is massive. So there's about, I think the World Health Organization had it at about 2 million deaths a year from acute lung illness from breathing in cooking fires. So it's a huge problem. And then when we get to what's called domestic energy poverty, that's effectively like you only have power certain hours a day. You might only have low voltage power, rampant blackouts and brownouts, etc. That's about half the world. It's a huge problem. We're very, very privileged in North America because our grid is actually fairly robust.
But even still, they had problems down in Texas. I
Yeah.
remember like the winters down in
Mhm.
Austin and Houston, they were having big issues with their electricity.
Absolutely. So can you imagine what it's like in other parts of the world if this is what it's the good version,
I've been
right?
to those other parts of the world. I know exactly what it's like.
Yeah, so that's part of the reason I got into all of this was to make renewables and alternative energy sources and a little more accessible to people. So there's a couple of things with that. In terms of where we're headed, I mentioned the energy ransoms. I think that's a big one that we're going to start to see more of. Another part has to do with decentralization of generation and storage. So this is starting to become more common. You hear more people talking about it. If you think of it like a water system and you're pumping water through a pipe, if you have one really big water tank and then one big hose that's going to take it to an area and then it splits out into, say, garden hoses that are going out to every house, instead of doing that, you can have smaller tanks of water and smaller hoses closer to each load. To each house, if it were. That's becoming much more common because it's more efficient. You have less places where everything can fall apart for lack of a better explanation. I mean, you have more redundancy in the system. So that's one of the things we're seeing more, decentralization. In a little more forward-looking stuff, I actually think we're going to see far more systems that are DC to DC or low voltage DC, even better. Um, I wouldn't say we're fully going back to revisiting of the current wars, which, if you don't know what the current wars, that was Edison and Tesla arguing over AC and DC. Um, reality is at the time we made the decision to use alternating current, AC power, because we didn't have the technology to send a DC current a long distance. But now that's really kind of biting us because the reality is anything that has a computer chip, and I do mean anything, has to have DC current. It requires direct current. So what we often do, we use, say, solar, and we're going to generate electricity. It's DC current. We flip it to AC, lose about 8 to 10% on the conversion, put it onto our grid wires. There's about 8, 9% loss on the lines. Then you pull it back and plug in your vehicle, your laptop, your phone, anything, and it needs DC power. So you flip it back and lose another 8 to 10%. So you've just lost between 25 and 30% of the energy just flipping back and forth by
Hmm.
simply going DC solar to a DC battery to a DC load. You save an enormous amount of energy. So I think we will start to see more of that. I don't think we're going to replace our whole electrical system. That's a bit over the top. But there's nothing that stops us, for example, when we're building new buildings or even doing retrofits, from putting in some DC wires and going from the solar panels you just put on your roof to a DC outlet in your house. And even now, interestingly, like my house is a bit newer. It was built in 2014. Well, it has USB outlets on the wall. The only thing is it's AC powered that's brought to the wall and then flipped. So there's nothing though that would stop us from having wires that were DC. And I'm
Hmm.
simplifying a little bit, but it's actually not the most complicated thing. And when you're talking about an energy efficiency gain of 25 to 30%, that's enormous. Like really, really enormous. Most energy efficiency projects, the goal is to come out with a 4 or 5% gain. 30 is a
Yeah.
whole lot more.
That's a massive amount. And I just like for the everyday person, they can just think of it as like the costs of your electricity and saving on your electrical bill at the end of the day, really.
Yeah, absolutely. And when you combine that with decentralization, you gain a lot of efficiency and you gain a lot more redundancy in your system. So you have less failure points. Now, it gets a bit tricky because utilities get paid when electrons go on wires. So they don't totally always love this type of talk. Now, to be fair, there are certainly much more forward-looking utilities who are all on board, and they're simply looking to be the providers of that equipment. And then there are those who have their heels maybe dug in a little bit harder, and are trying to push everything through the grid. To my way of thinking, I think that's not the best approach. I think we have to make our grid more redundant, more robust, but not that as the only solution. It's very, very expensive, and there's things that we can do that provide better redundancy, better efficiency at a lower cost.
Yes, but that doesn't drive capitalism for those big giant conglomerates who got to be the number one people. They want to stay the number one people.
Fair enough. That is often the case. It's one of the things that I find myself frequently having to fight.
Yes. Oh my goodness. Okay, Connie, this has been such an enlightening conversation. I love that you are out there doing this work for us because, the environment needs to stay around for us to stay around. And it's folks like yourself out there who are helping us move into the right direction. I'm very proud to know you and have you as a friend of mine because I love everything that you're doing. So thank you so much. Where can folks find out more about Grengine, about yourself, if they want to maybe buy batteries for their cottages or something like that? Where can they go?
Sure. So probably the easiest is go to the website, which is just www.grengine.com. And Grengine is just green engine smashed together. So GR engine, it's a pretty easy one to find. So that's probably the first thing you could do. Otherwise, you could reach out by email or phone and just chat with somebody. Um, yeah, that's probably the best thing to do. Check us out on social media, maybe.
Perfect. Awesome. I'll make sure to have all those links in the show notes. It's been an absolute delight. Oh, my brain is not functioning. An absolute delight having you, Connie. Thank you so much for being on the podcast today.
Well, thanks for having me. It's always a pleasure to chat.